What is digital engineering and how MBSE fits in this approach? What are the main challenges that systems engineers face in their everyday work? Why managers should consider digital engineering methodology as a game changer to deliver high-quality products faster and saving costs? What are the must-have tools required to adopt a digital engineering methodology? We are going today to address these and other essential topics to understand what is digital engineering and MBSE with Bernard Dion, Synopsys Fellow. Let's kick off the first episode of the ANSYS model-based conversation series. Thank you for joining me, Bernard. There's a lot of buzz around digital engineering, but also a lot of confusion. So let's break down what actually is, why leaders care, and how teams can get started without boggling the ocean. So my first question will be very simple. What is digital engineering and how it's different from the traditional systems engineering?
Yeah, so hello, Raquel. So let's go into these questions. So first of all, digital engineering is an integrated digital approach that is using models as a continuum across disciplines to support lifecycle activities from initial concept to system disposal. And it differs from system engineering because it focuses on the overall lifecycle. If I look at system engineering, that's the life cycle and the requirements for each phase of the life cycle. One key point is that we provide a model-based digital engineering methodology. It's not based on documents, it's based on models. And so the methodology that we've developed is in fact a system LV2 model. And why is that so? Well, for us, while doing it, we benefit from the model-based approach in building the methodology. So there is a single source of truth for the methodology, which is the model, not document. In order to use it, you start your project as a model in System LV2, and the first thing you do is that you import the methodology, and then you can use it. You can use these templates, these Lego pieces, they are available, and you use them to progressively build your project. So it's readily available as a model. It's also interesting for and very useful for our users because in some of the cases they will need to customize the methodology and to their own needs. Maybe they want to replace elements, to add to it, to suppress some elements of it, and this they can do it because it's a model. And finally, it's also good for our users because it's opening the door to automation. For example, you could have verification rules that the methodology is obeyed, and this is possible because it is a model. And if we project ourselves a bit further, it's also opening the door for future AI assistants in applying the methodology. So this is really good at all levels, I would say.
Let's talk now about the end users, so to speak, of this methodology, the systems engineers, because they will be the ones that will be touching the models and sharing with the rest of the team. So what are, from your point of view, the daily challenges that systems engineering are facing, and how this digital engineering methodology can help them to overcome those challenges?
Yeah, so I can list a few challenges that they encounter. So first of all, communication with stakeholders in a context where complexity is increasing every day is a challenge, and there is communication with users, with customers, with policymakers. So lots of things to integrate there. So that's the first difficulty. Then we they need to spend more time doing engineering than reviewing documents. So avoiding having a pile of documents that are not really coordinated is that's a challenge. It's difficult to establish common practices across the organization, to integrate with other disciplines of engineering like physics, cybersecurity, safety, embedded software. You know, traditionally, organizations have been siloed, and it's difficult to overcome this kind of difficulty. Another point is that it's difficult to organize work so that many things can be done concurrently and iteratively while engineering a system. So that's definitely a topic. And last but not least, I would say that there is a challenge in adopting practices that were introduced with software engineering. So I would like to mention agile development, DevSecOps, automation, configuration management, architecture as code. All these things are now very well deployed in software engineering, but they are not yet in systems, and they need to be.
I would like to know your opinion about why is digital engineering methodology or digital engineering in general becoming such a priority across industry right now, and which are the main industries that will have the biggest gains from digital engineering approach?
Okay, so first of all, why digital engineering? Well, this is because there is a need to meet these challenges that we've listed. Now, about the industries, personally, I see no limitation in the domain. Of course, if you take like big projects very big projects in aeronautics, and with collaboration across continents and with many suppliers, there is no way to build these systems and to the needs of their customers, be them civilian customers or government organizations. So in this context, it is already deployed in some way, and it could not be done otherwise. But the same applies to other domains. Take automotive, take medical, take industrial systems. I see no limitation where it would not, with domains where it would not apply. So no, it's for every industry, definitely.
And considering that it is something that is beneficial for any industry, can we say that also digital engineering methodology is helping them to adopt the industry standards as well?
So absolutely yes. And the methodology that we are building is compliant with a number of industry standards. I would cite the first one, which is that we comply with a standard called ISO 15288, which is about systems and software engineering lifecycle processes. So we comply with it, which means that when our users are using methodologies, they comply with the standard. Now, why is it important? Well, complying with standard provides a lot of benefits in terms of compatibility, interoperability, reduction of cost, and efficiency of the resulting system. So this is a key point for our customers, and at the level of Synopsys or ANSYS, we systematically support standards because we know that this is absolutely key for our customers.
Well, if a program wants to start today, what is the first practical step that organization should follow? And apart from that, I would like to know if is there any kind of maturity level required to start with digital engineering methodology?
Yeah, so So no, there is no limit and no required maturity, but what I propose is that the maturity is assessed. So and it should be assessed in a context that is usually called digital transformation of the enterprise. And so there should be an assessment of the situation and then a decision to go in more precise directions with respect to this digital transformation. Now, the second thing I'd like to say is that there is a very good reference which is provided by ENCOSI, the Council on System Engineering, and which is the System Engineering Handbook, which provides a description of the typical processes for doing system engineering. And so this is a very good reference. And this handbook is used as the basis to run a program, which is the INCOSI certification program for system engineers. So that's a good way to introduce people to this domain. And where you discover that doing system engineering is not just doing SysML, which is a language. There is much more. Now, to be more specific on training activities to get into it, so of course there is the SysML v2 language that people have to be trained on, and it's a new language, so it's extremely important to be correctly trained on the language. Then there is the tool. So on our side, we provide a tool that is called SAM, and we provide training on the tool. And then there is the methodology, and there should be training on the methodology. So you see, there are things at various levels, digital transformation at enterprise level, getting closer to the standard workflows and processes with INCOSI, and then being trained on language, tool, and methodology.
What are the main ROI benefits that you would highlight if you are, for example, in front of a VP trying to change their mindset and also encouraging them to adopt the digital engineering methodology? Can you summarize them in 2 or 3 points, for example?
Yeah, I'll try to be short. So at least 3 ROI benefits. One, that should talk to leadership. One is cost reduction. So digital engineering is about making informed decisions based on simulation and analysis. So this is meant to save cost because you do these decisions early in the process, and you do this on a basis that is simulation and analysis. So you would save cost of physical testing, for example, because you do it through models. So that's the first one. Increase productivity. So the guidance provided by the methodology should largely increase productivity, and you develop self-consistent models so that improves communication. So that goes in the direction of productivity. And finally, third benefit I would list is enhanced quality, because doing this in a way that is methodic reduces failures. It reduces warranty cost, enhancing customer satisfaction. So this is all related to enhancement of quality.
Now that we have covered almost which are the benefits, which are the main stakeholders of this methodology, how the organization can overcome the risk or the blockers when they are applying this methodology, let's talk about the future. How do you see digital engineering methodology evolving over 5, maybe 10 years? What is your take on this?
Okay, so let's consider a few important points. The first one I'd like to mention is digital thread. So this is a fundamental concept to connect data within the digital environment. and to make sure that you really access data that is up to date, that can be trusted. And so if I tell you about our own current situation, is that we have some of these capabilities already in the tools, like connection to requirements management tool. That also we work with partners. I'd like to mention SBE Vision as a partner to provide a broader implementation of digital threads. And this can be done for every connection topic. For example, we've been working on connecting SysML v1 model to SysML v2 models. This is important because when you start, you have existing stuff that is in the previous generation, and you cannot throw everything away and translate it immediately. So communication may be important, and that's the topic. That's a digital thread. Also, just to tell you, we've started to define and to model this digital thread in the methodology itself. This is the beginning, and it's work for us very important in the next year or next 2 years to completely implement this digital thread. So that's one topic. Second topic that is linked to digital engineering, this is digital twin. So this is about connecting the system model and real physical object, physical systems. So this is also a topic where we have existing activities, and we have a connection between our SysML tool, SAM, Model Center, which is establishing connections, and our Twin Builder product, which is all about digital twins. So this is something that is existing, that is going to be more and more important in the years to come. So that's the second topic. Third topic I'm seeing is automation. And so as we progress in the description of the processes, and also as our SysML v2 modeling capabilities are progressing, we will want to automate some of the activities I just described to you, like managing work breakdown structure is a good example. And also we said automating verification rules, that's another example of automation. Automating V&V activities will allow to build DevSecOps cycles and help to do continuous integration, continuous deployment. And so this is all about automating activities that typically were performed by hand. So that's a very important topic for the efficiency overall of the system development. I will cite also in the key topics for the future domain-specific languages. So if you are in say you are in aeronautics, you may need to comply with the phase standard, which is about avionics, or integrated modular avionics, another standard. If you are in automotive, you may want to comply with AUTOSAR. So in the SysML v1 generation, this was done with profiles. And in SysML v2, this will be done with metadata and language extensions. So, but this needs to be done. So this is a key topic for the future, because people need to work with the elements that are their domain elements. So this is the DSL capability that is there. And finally, I like to finish with AI. And I see it as a fundamental activity for digital engineering, because we said that this is giving the possibility to connect disciplines. But when you connect disciplines, you need to establish very precise workflows and exercise these workflows. And we see AI as as an enabler of these, fundamental enabler of these workflows. And so this should be a fundamental topic to get this AI support to be even more efficient. And this is also at the level of a company like as Synopsys. This is for the overall company a very, very important topic, and it's also important in this digital engineering activity. So these are examples of things for the future, and with many years to mature all these topics.
Thank you very much, Bernard. It was everything clear and very practical, so thank you for helping us to separate buzzwords for the real practice, and thank you for your time. Thank you, Bernard.
Thank you very much.
It was a pleasure to have you in our first episode. Thank you.
My pleasure.